In this video, I'll walk you through the post-lab for Lab 4 identification of cations and anions. The good news here is that the hard part of this experiment is actually doing the experiment. The post-lab is going to be really straightforward. So I'm just flipping through all of the procedure here. We get to the very end. Here's our post-lab assignment. So you will have, at this point, this data table completely filled out with all of the observations that you made. You'll have like color changes and whatever kind of codes you use to indicate all of your observations. You'll also have information down here for your unknown anion. And the first thing that you're being asked to do is identify the anion, the unknown anion right here. So to do this, first of all, the first thing that I want to do is just sort of remind you that your anions, your unknown anions, are in this part of the data table. These were all the solutions that you tested with. And the unknown anions are hidden within these ionic compounds. Because Mother Nature doesn't let us just have CO32- hanging out in a beaker. We have to use NH42 CO3. This is our source of the CO32-. And the same thing with the chloride, sodium chloride, NaCl. This is just serving as our source of Cl-. This is our source of I-. This is our source of phosphate, PO43-. And this is our source of sulfate, SO42-. So you can really just kind of ignore these labels and just focus on the labels of the anions. What you want to do is take a look at the observations that you made for your unknown, and you are going to find the one row of data that matches up perfectly with your unknown observations. One of these rows should match up perfectly with your unknown. Let's just say for me that it's this row right here, complete perfect match. And if that's the case, that tells me that this is my unknown anion, and I would indicate that by circling this guy right here. Now it is possible that you don't have any one row that matches up perfectly, but if that's the case, you just want to find the one row that matches up the most, the one that is the most similar to your unknown. That will be your identity of your anion. And then we're going to repeat that with your cation. So same thing, these are the solutions that you used to test, and these are all of the cations hidden in these ionic compounds. So down here are the actual cations themselves, and then up here in this spot, I'm just going to write the actual cations. AgNO3, that's a source of Ag+. Then we have aluminum, Al3+, we have calcium, Ca2+, copper 2, which is Cu2+, nickel 2, which is Ni2+, lead 2, which is Pb2+, and potassium. And again, you can kind of like ignore these full ionic compounds and just focus on the cation. So just like in the previous data table, you have a bunch of data here for your unknown cation, UC, and you're looking for the one row of data, whatever it might be, that matches up perfectly or as close as possible to the observations that you made for your unknown. So let's say for me that this row matched up perfectly with my unknown. I would say that meant that my unknown was the Cu2+ ion, and I would circle this as my unknown. This next question is really the only hard part on this post lab. This is giving you a scenario where you're just going to kind of apply these tests that you did. This is getting you ready for the next couple of weeks of lab. So this is telling us that we have an unknown ionic compound. This means, by saying ionic compound, this means that we have both an unknown anion and an unknown cation. So we have two unknowns together, an anion with a cation. And it's giving us some information about observations of the unknown anion and cation. So for example, the first thing that we see, it forms a white solid with AgNO3. So what we want to do with that information is we want to look at our observations to see what might form a white solid with AgNO3. When we're doing this, we don't want to be focusing on AgNO3 when we're using it as a cation or anion. We want to be looking for AgNO3 when we were using it as a test reagent or a test chemical. So AgNO3, we can see here, was never used in our detection of cations, which means that AgNO3 is only used to detect anions. So let's go to our anion data table. Over here, we've got AgNO3. We're looking for, the question said, I got to flip back to it, white solid with AgNO3. So in this area, somewhere in our tests with AgNO3, one of these substances produced something that was white. White solid, it doesn't mean that it was actually a chunk like a rock. It may have still been looking like it's in a liquid because it would be mixed in a solution. But anywhere that you have something that is white, that is going to tell you, oh, hey, that's what your anion is. So whatever you have in this row underneath or in this column underneath AgNO3, whatever you have that is white, I'm just going to say it's carbonate, that will be your unknown anion. I just picked carbonate. I don't think that carbonate is correct, but I'm just going to kind of make a note. White with AgNO3 is carbonate, CO3 2-. And again, this is actually, I don't think that this is right. I'm just writing it down just for the purposes of writing it down, just to do an example. The next piece of information we have here, it says, I'm going to use a different color, a blue solid with NH4,2CO3. So what we need to do again is go look at our test reagents, NH4,2CO3. There it is. And we want to look for, in this column, something that formed a blue solid. Maybe there's 2 things, maybe there's 3 things, maybe there's only 1 thing. We don't know for sure. Let's just say that both of these formed blue solids, Ag plus and Al3 plus. So a blue with our NH4,2CO3, that would mean maybe it's silver or maybe it is aluminum. It can't be both. It has to be one or the other. We just don't have enough information to figure out which one it is. We also have some more information. Blue solid with NaOH. Okay, so we're going to go back to our NaOH again. It's right here. We should also we should take a look. Is that also being used for an anion? No, it's not. So NaOH, what could we be seeing that would form a blue solid with NaOH? Maybe it's aluminum, Al3 plus. So blue with NaOH, we've decided that that is probably aluminum. And you're just going to continue doing this. So the next one up would be a brown solid with NaI. You'd go find that. A blue liquid with NH3. You'd go find that. Does not react with HNO3, does not react with BaCl2, does not react. Your observations are going to be a little bit more detailed than what I'm writing here. Like, you're going to have probably way more possibilities when you first start this off. But as you work your way through all of these different hints, you should be able to narrow down what the cation is and what the anion is. So you should end up with just one possible cation and one possible anion. Now let's just pretend like I've done that and I ended up with the anion CO3 2- and the cation Al3L+. Your last job is just going to be to combine them together in a way that gives you an overall charge neutral molecule. Something along those lines. So you're going to want to write it in the form of an ionic compound, not as individual cations and anions. And like I said, this is going to be the trickiest part of this whole entire post lab. So, take some time, make good notes, and if you have questions, if you get stuck, just ask.